Gentlemen, thank you for those presentations. Very chilling presentations at that. I think we could all use some global warming. We'd like to open up to questions. I'm going to go ahead and begin and ask the first question, and then if you do have a question, go ahead and raise your hand, and John will come and find you. You'll be the first right over there after me. We've heard a lot about the climate models and their failures, in particular in the last few years, as they've deviated from reality and what the temperatures have shown us. Joe, this question is to you. How about these short-range weather forecasting models? Did any of them foresee some of these cold events that you guys have talked about? Are they any good?
The short-range 2-week models, the best one is the European model. It goes out 2 weeks.
What about longer range, maybe monthly or half a year?
There is a climate model that Joe and I trust most, and that is the Jospeh model, the Japanese model that seems to do it.
The JMA, too.
And the JMA.
Second El Nino years, but the JMA has been deadly now. It's amazing. Its June forecast for July beat the CFSV2 in the European, because you've seen how cold it is in July. We have cold July. I'm sorry. Can't hear. The JMA, I really believe.
Where's the microphone?
That has turned into the guru. Since the middle of last winter, it's just been deadly, and when it supports what Joe and I come up with, what we call an independent consensus, where we look at stuff and then we talk it over and see where our common points are. And when we had that JMA backing, we had it for the winter. It really helped us out.
So you're basically saying that there is one or two models that are fairly good at forecasting these shorter 6 months range,
Yeah,
perhaps. Okay.
I believe that, but I don't want anybody in the private sector knowing that, because you don't need the competition.
Very good. Okay. First question right over here.
I haven't heard much.
Oh,
Sir.
right behind you. Yeah, he's got the mic.
Yeah. My question is mainly directed to Joe DeLeo. And I think Joe Bastardi, too, who works with you. I'm surprised the solar effects. I've been following them for many years, and you get the solar changes are so small, I'm surprised you can correlate them with the PDO and the AMO. Do you really think there's a physical link there? And these ocean changes, the energy involved with those is much more than any small changes in the solar activity.
Well, certainly the irradiance is a small change factor. It's 0.1%, which is why the IPCC models downplay the solar, which is also not modeled in the forecast models on the short term. And by the way, in the winter of 2001 and 2, we had a very, very high solar flux, and the forecast models were awful. They kept going for cold, and we never got cold because there was a tremendous amount of solar flux. Ultraviolet radiation causes ozone warming, which shrinks the polar vortex, and we had a very zonal winter in the United States and Europe. And but it's those amplifiers that are important. It's that UV. It's the Svensmark cosmic ray cloud enhancement, 1 or 2% change in albedo. And we see, Joe and I found a very strong correlation between low geomagnetic years and high latitude blocking in the winter. So we do believe that the sun plays a key role, and we use it as part of our forecast.
Fred?
Yes, well, I would like to emphasize that the irradiation changes are small, but it's the sunspot frequency that is very important. And we know that the Little Ice Age in the 1600s was due to the fact there were no sunspots for 50 years. And we could predict the very cold winters we had 2010-11 by comparing the activity with the Dalton minimum and the PDO combination. So it's a combination of sunspot frequency and ocean currents that controls the majority of the climate on the northern hemisphere. The southern hemisphere is another story.
Next question, right here.
The question has to do with something that wasn't discussed during, at least in the conferences that I've been attending, and that has to do with the effect of these apparently falling temperatures over the next decades and agriculture or food production of all the grains. And I'd like to have you, either Joe, address that issue.
Actually, I'm coming out very shortly with a white paper that's going to be presented, published by a large agricultural and energy firm and the CME that will discuss what if it cools instead of warms. A gentle warming and the government forecast of its impact of 3-degree warming on agriculture, decreased yields and all of that is not the likely scenario. That, in fact, with increased fertilization from CO2, a warming would benefit agriculture. If we get colder, the growing areas will, well, just growing season will shrink. The growing areas will shift south, not north, as they're projected, and to less fertile soils. There'll be a problem for agriculture and a problem for energy and everyone else.
I'd like to hear a little bit from Craig Idso, because he knows more about this than the rest of us ever forgot.
Well, you have to come to my talk tomorrow to hear that answer. Or afterwards. Talk to me afterwards. Another question back there.
Okay, I got a question, I guess, for all three of you, but probably Joe in particular, that the PDO and the AMO are really more regional phenomena than global, and PDO affects Alaska, Pacific Rim, AMO, East Coast, Europe, and so on. Okay, there's been a lot of chit-chat about the stadium wave effect, where this whole thing propagates around the globe. Do you put any stock in that, and do you see any predictive capability there?
Good question.
Have you heard of the stadium wave? I have never heard of the stadium wave effect.
It's basically that the PDO kicks a phase shift in the PDO, lags or leads a phase shift in the AMO, which then leads to the Arctic oscillation, and the whole thing just goes around in a circle every 60 years.
The PDO is a cycle around 60, the AMO is more like 65 to 70, and it does seem like the PDO leads the AMO, and the coldest weather occurs when both are negative, and the warmest weather when both are positive. They were both positive in the 1930s, and in 2005 and in 1998, both negative in the 1970s, late 1970s, and the 19-teens. So when they work together, it amplifies the affect the temperature.
And I think that's a great question. How much does one of these large-scale atmospheric phenomena affect the next one closest to it spatially, which affects the next one? How much are they interrelated and intercorrelated? I think that's kind of what you're getting at, and that's something I really haven't seen much in the literature about. But I would suspect there's going to be some give and take and pull and play between each of them as it travels away. I wouldn't be surprised. Yeah. Well, that'd be a good one to follow up with. Thank you for bringing that up. Next question.
Well, yes. May I make an additional comment?
Yeah.
I showed a diagram of the global temperatures zigzagging up and turning around 2008. Well, that's the PDO effect, but the general trend was going upwards, and that, I believe, is a solar effect. But now the solar effect is turning around also. So this now is a combination of negative PDO and solar intensity, not intensity, but sunspot frequency going down very low. So now the whole thing drops down dramatically.
It's a very knotty issue. It's fun to get involved and try to ferret some of these things out, the various influences. Go ahead.
The warm pool off the coast of Alaska last year, what is the cause and how deep is that warm pool, and how much warmer is it than the surrounding ocean?
It was unusually deep, and at one time the anomalies were as much as 7 degrees above the normal, so it was significant. And it started as a result of the super La Nina in 2010 and 11 that generated a warm pool to the north and west and moved over northwest of Hawaii, which favors warm winters in the United States, and drifted to the north and east. And when it got into the Gulf of Alaska, that's when the polar vortex developed.
Good. Another question. Next question.
I've read somewhere that when the AMO is positive, there's a tendency for drought in the western United States. Can you speak to that point?
It's a combination of the AMO and PDO. Some very good work was done by McCabe and Betancourt in 2004 that showed that when the AMO is positive and the PDO is negative, like we've seen this decade, and like we saw in the 50s, you get drought in Texas back into the Southwest, and that's certainly been the case.
I think we got time for one more question.
Yes.
Some of the global warming scientists are saying that there's going to be a change, that the warming is going to start increasing possibly next year or by 2020. Is there any plausible evidence pointing towards that idea? And how long do you foresee from your research of the global cooling continuing or even deepening?
I think Woody Allen said it best. Prediction is very hard, especially when it involves the future. I am certainly not one in a position to make predictions about future weather. I mean, a day or two, maybe. The Joe can go a little bit farther than that, but I think that's rather dicey territory to get into.
Anybody else want to comment?
Well, Professor Abdulsamatov showed us a lot of solar physics, and when being acquainted with the different solar cycles, I think you can do a fairly good prediction of what the future looks like, and that is what he showed and what I showed in my talk.
Very good. Do we have time for one more, John, or we're done, I guess? One more, real quick. Larry? Just stand up and tell us what the question. I'll repeat it. Yeah.
If I think of how physics works in terms of laws and theories and predictions and testings, we've got scenarios and we have quantitative relationships based on which we make our predictions. Now, in seeing what's going on with global warming over the years, I don't know what the basic equations are. I don't know what the basic theory is. As far as I know, it's fluid mechanics. You have Navier-Stokes equation. There's still a prize for solving it. What is the theory that anyone is using, which has been verified, that enables people to predict what's going to happen with the climate?
Well, Larry, it's a good question you ask, and the answer is, well, we understand perfectly well some laws of gravity, but if I drop an egg, I will be no good at predicting where the stuff is going to splatter. There's just too many variables to handle, and we just don't have, we just don't understand all the interactions that are going to go on, and we just have to deal with it statistically, and we don't even know enough statistics. So, well, I mean, we have some, for example, Fred is talking about the comparison of solar cycle 24 with number 5, I guess. Well, that is reasoning by analogy, and that can take you so far. You know, it could wind up being an accurate prediction, but it certainly isn't on the scale of the kind of prediction we can make with astronomy where we know exactly where Jupiter is going to be tonight. We just don't know.
Well, with that, our time is up. Please join me in thanking our panel, and thank you for attending.